Hi, this is Karthika, Faculty of Physics, working in SNS College of Technology. So in this session, I am going to explain about the crystal parameters of simple cubic structure. So before that, we just recall what is crystalline and what is amorphous. So crystalline material is nothing but in that material, the atoms are arranged in a periodic or regular manners. That is called a crystalline material. Examples is nothing but a metals. If we go with amorphous, the arrangement of atom becomes irregular. So for example, if we take a rubber, plastic and wood material, that comes under the amorphous in nature. So with that, here we have some characteristic parameters of crystalline structure. So these are the basic definition. The first one is number of atoms per unit cell. Second one, atomic radius. Third one, coordination number. And fourth one, atomic packing factor. So we'll see the basic definition of these four parameters. So first one is number of atoms per unit cell. So the number of atoms per unit cell is nothing but total count of the atoms which belong entirely to the single unit cell in a crystal lattice. So this taking into account that atoms at corner, faces or center shared with neighboring unit cell. So if we see this number of atoms per unit cell for a simple cubic structure is 1, for body centered cubic that 2, and for face centered cubic that is 4, and finally the n face centered cubic cell is nothing but 2 atoms per unit cell. For simple cubic structure, the example is nothing but polonium, for BCC calcium chloride, for FCC sodium chloride and all. So the second one is atomic radius. So atomic radius is nothing but in picture we can see the two nearest neighboring atoms. So half distance between the two nearest neighboring atom is called as a atomic radius. Next one is the coordination number. Coordination number is nothing but number of nearest neighboring atoms to the particular atom. So that count is called the coordination number. Finally, the atomic packing factor. So the atomic packing factor is nothing but how much the unit cell, how much percentage of the unit cell is filled by the atoms and how much can be the empty. So this can be calculated with the formula called the volume of the atom in a unit cell by total volume of the unit cell. This is the basic formula for atomic packing factor. So these parameters can be calculated for the different crystal structures. So first here we are seeing the simple cubic structure. The number of atoms per unit cell. In picture we can see cubical structure have 8 corner atoms. So 8 corner atoms can be shared by 8 units. So this can be calculated as 1 by 8 into 8, that is nothing but 1. The number of atoms per unit cell is nothing but a 1. The next one is atomic radius. This is nothing but half the distance between two nearest neighboring atom. So that is denoted by A. Half the distance is nothing but radius of the atom, that is denoted by 2r. So A is equal to 2r, or we can write r is nothing but A by 2. So next parameter is coordination number. Coordination number is nothing but number of nearest neighboring atom. So here we can take any corner atom or consider a corner atom that have a 6 coordination number, that is 6 nearest neighboring atom is there. So that red color atom is a corner atom. So for that all the nearest neighbors are 6. All are in a equal distance. So next one is the packing factor. So packing factor formula is nothing but number of atoms per unit cell into volume of one atom by total volume of the cube. So here the number of atom is nothing but 1. Volume of the one atom is nothing but volume of the sphere, that is 4 by 3 pi r cube, and volume of the unit cell is nothing but a cube if the side is a. By simplifying the equation, we will get nearly 52% of the unit cell is filled here, remaining the 48% of the simple cubic structure is empty. So the example for a simple cubic structure is polonium. Like simple cubic structure, we can calculate these parameters for a different structure called BCC, that is body centered cubic, face centered cubic, and hexagonal closed pack structure. So here we can see the atomic packing factor for FCC and the hexagonal closed packed structures are equal. So that can be seen in the next session. Thank you.